Most people use coding agents like Claude Code to build toy applications and demos. But if you want to make money out of these tools, you need to start building things that businesses actually need. I just used Claude Code to build this brand monitoring app. Now, this is incredibly valuable. We can specify any brand that we want to track, like Freshdesk. We can specify any prompts that we want to test for, and then select the providers we want to test against, like ChatGPT, Perplexity, Gemini, Grok, Copilot, and just normal Google search results as well. And now we're running that prompt against each of these providers to see if the brand is even mentioned at all by the LLM, or we can even gauge what the opinion or sentiment is from the different models. And now that we have all the responses back, we can see that for the prompt, what is the best customer support platform, Freshdesk is actually mentioned by all of these providers, as well as the Google search results. But let's change it to a different brand, like Gorgias, which is also a customer support platform. So check this out. So Gorgias is actually recommended by Perplexity, Gemini, Grok, and Copilot, and it is available in the Google results, but ChatGPT actually did not mention this brand. So why is this a big deal? Well, imagine you're working for Gorgias and you've spent years doing search engine optimization to improve your position in the Google results. But now in the era of AI assistants, you notice that there's fewer and fewer traffic to your application. And that is because tools like ChatGPT and Gemini and Copilot are quickly becoming the tools that people use every day to look up tool recommendations or even local service providers. So not being recommended by something like ChatGPT can actually be a really big deal in today's day and age. And by having a tool like this available in your company, you can definitely have a look at what all these different models are saying about you. And in the case of something like ChatGPT, you can dive into the details to figure out what you need to do to get into those results. Or of course, you can take a tool like this and plug it into your greater SEO ecosystem. Now, I'm not going to spend too much time on this, but I will link this article in the description of the video. So if you really are into SEO and you want to learn more about this concept of search everywhere, this will definitely be useful to you. That people are no longer just using Google to perform searches. They're now moving search away to different platforms, including AI platforms like ChatGPT. And that's why I think something like an AI brand monitor can be extremely useful to these companies. And just to really try and land the point that I'm trying to make, ChatGPT has over 2.8 billion monthly active users. So not being mentioned in this platform is really a big deal, and brands would want to know about it. Great, so at this point we've identified a potential business opportunity. We now know why an AI brand monitor would be useful to companies. Now the next question is, how do we actually build this? And I'm not referring to the underlying tech stack yet, or even which coding agent we're going to use. We need to determine what is going to make this application unique compared to all the others out there. Now, your first instinct might be to simply hook up all the different API endpoints for each of these providers, or to maybe use a service like OpenRouter, which is sort of a unified API for interacting with all of these providers as well. But for this application, that's actually not going to be sufficient. You see, when we pass this prompt to the LLM, we actually don't want to call the API endpoint directly, because we're not trying to test the API. We actually want to get the exact feedback that the customer-facing tools would give. For example, with ChatGPT, we don't want to call the OpenAI real-time API or anything like that. And we definitely don't want to call it through something like OpenRouter either. Instead, what I'm referring to is the response that the user would get by using ChatGPT, the user-facing web application. And believe it or not, these results are different to what you would get from the API. And that is because these platforms are optimized for user experience, and they already include a whole bunch of different features and capabilities that's not necessarily available in the API. And furthermore, things like Copilot is used by more and more people every day because it's baked into so many platforms and Windows itself. And there's no public-facing API for Copilot at all. And of course, when I'm referring to Google Gemini, I'm actually not referring to Google Gemini's API either. I'm referring to the actual AI mode within Google. So if you perform a search on Google, you can actually click on AI mode, and that pulls you into this user interface. And another thing to call out is that a lot of these responses are actually based on your geolocation. So an API call will only sort of give us the response from the model, but if we scrape these applications, we will get the actual user experience. And for a brand monitoring platform, that is what we want. And just from an operations point of view, we need the ability to retry. So if for some reason we couldn't scrape the response, we just want to try again. We also want to be able to handle the different response formats from these different platforms. And finally, as our application grows, we must be able to run reliably at scale. So at high level, this is our goal for our application. If we can build this, then we know we can add value to businesses. And if I jump back to our demo for a second, this is exactly how this application is going to work. For each of these providers, we are not going to call the APIs directly, but we are in fact scraping the responses from their actual applications. And this app will feature all of the ops that we just discussed. We'll be able to retry these attempts. We will be able to handle all the different responses returned by these providers. This app will be reliable and scalable as we grow our user base. I think it's time that we actually now dive into the code and set up our project. In terms of building the solution, I am going to be using Claude Code, but of course you can use any coding agent you want. In order to respect your time and to avoid this video getting too long, I've already set up a boilerplate project that you can copy for free. I'll link to this GitHub repository in the description. Simply go to this page and then click on code. And now you can either download it as a zip file and extract it on your machine, or you can just clone this repository using this link. Then open a project in a code editor, like VS Code that I'm using here. Then open up a terminal window. And all we have to do is install all of the dependencies by running npm install. And actually, while this is installing, let me just show you what we currently have. So in the package.json file, this is a really simple Next.js application that uses React as the front end. We will be using SQLite as our database and Drizzle ORM to connect our app to our database. Nothing crazy at all. We can also start a dev server by running the command npm run dev. Then we can open up this page. So sorry for the funny edit, but I've actually run into issues with Claude Code during recording. When I try to use the Claude Code CLI at all, I get this error message and I just couldn't get around it. So I suspect there's some kind of bug that was introduced with the latest version of Claude Code, or there's some kind of downtime. So just to mix things up a bit, I'm actually going to use Cursor for the remainder of this tutorial, but again, feel free to use Claude Code or any agent you want. I'll be using Opus 4.6 in Cursor. So again, to start a dev server, we'll simply run the command npm run dev. So this includes a really simple design. And by the way, if you do want to learn how to build beautiful UIs, I do have a dedicated video on that, which I'll link to in the description of this video as well. And you should see a card on the screen. I just didn't want to spend a lot of time setting up the project and building the UI when that's really not the focus of this video. And this app has some really basic functionality only, like we've got our projects, we can create a new project like Fresh Desk, we can enter a brand like Fresh Desk as well. Let's create this project. And we can add a prompt like, what are the best customer support platforms? Let's add this prompt. And of course, we can see all of our providers over here. But when we click on run scan, nothing is going to work. That's what we will implement in this app. And by the way, if you were curious as to where the data is actually being stored, we've got this SQLite database in the project. And in that database, we have a project table. And here we installed that Fresh Desk entry. We also have a prompts table for all of our prompts as well. Now that we have our project set up, let's see how we can implement the unique selling point of our application, scraping the responses from each of these different providers. Alright, so how do we now implement this button? Remember, we do not want to just call the APIs, we actually want to scrape these different platforms. And after doing some research on different platforms and ways to do this, I landed on this article from Bright Data. Now, for full transparency, they are sponsoring this video, but I would have used this service irrespective of whether or not they would have sponsored me. This document provides an overview of the AI-powered web scrapers integrated into our systems. These scrapers interact with advanced AI models to retrieve structured responses to their prompts, including relevant metadata such as sources, citations, and contextual information. Our platform supports the following AI scrapers: ChatGPT, and do take note, they're not saying OpenAI, they are referring to the actual ChatGPT website. Perplexity, Gemini, Grok, Google AI mode. So it's not the Gemini API, it's the actual AI mode that users interact with, as well as Copilot. They do have a section here on how these AI scrapers are different to traditional SERP scraping. So SERP is just basically calling the search engines to see what Google would have responded with, or Bing, or even some other tools. So this can still be useful in our application because we do want to gauge if the brand would have been returned in the Google results, but we also want to see what these different AI providers are saying about the brand. Now, this table is also important. So it shows for each provider, the scraper actually includes. One thing I mentioned previously is that we do want to get country-specific information back. So if the user from a certain country had to use ChatGPT, would our product still be recommended, or our service or our company? So we can see here that for the ChatGPT scraper, it does support available countries. There's also return back any hyperlinks and citations. Then if we jump over to the API documentation and we go to the scraper docs, this will tell us exactly how we can invoke the scraper and get those responses back. Now, we will definitely be using the synchronous request, which is just a simple post request where we call this endpoint on Bright Data, which is basically the trigger for this entire scraping process. So basically our app is the trigger. So when we hit the run scan button, it's going to call this request to Bright Data for one of these specific providers like ChatGPT. So our app will call Bright Data, passing in some information, like maybe the URL to the website, the prompt, the country, whatever this data set in Bright Data actually handles. And the type of information that we pass to Bright Data will depend on the provider. So Bright Data will go to ChatGPT and try to scrape the data. Now, there's basically two paths here. If for some reason we get a response back immediately, so I think it's within a minute, Bright Data will simply return the full response back to our application, so we can handle it immediately. But if this exceeds the maximum time, which I think is 1 minute, Bright Data will pass back a snapshot ID. So we can use that ID to just keep checking in on Bright Data to see what the progress is. So that means our app can also implement some kind of polling logic. We can go to the monitor progress endpoint, this guy over here, and this is a get endpoint where we simply pass in the snapshot ID. And Bright Data will give us some kind of status like it's still running or it's complete. If the scraper is complete, we should actually receive the response at this point in time. But they also have this get snapshot data API, which we can invoke at any time to retrieve the results from a scraped run. So basically for the polling, we'll either get some kind of status that says that it's maybe still running, or we'll receive the results if scraping is complete. And another cool thing is that this pattern is consistent for any of the providers that we're trying to call. So we can easily swap out ChatGPT for Copilot, and this pattern is exactly the same. We'll just pass a different dataset ID that represents this source, and we might just have to adjust the data being passed to it. But of course, we'll get the coding agent to handle all of this. And by the way, this is an established pattern for production applications. This whole flow of trigger, polling, and downloading the results is already production ready. And for those of you who are familiar with SEO, you might be familiar with tools like Ahref or SEMrush. And these tools all use this exact same pattern to collect their data. Alright, cool. So we now have a service provider that we can use to assist us with the actual scraping process. Now, let's set all of this up in our project. And we're not going to code any of this ourselves. We are going to get our coding agent to do all the heavy lifting, but I'm an advocate on my channel of teaching people to read the docs. It's important that you still understand your solution, so if you have to scale it and support it in the future, you know exactly what went into it. The first step is to sign up with Bright Data. So we can just sign up for a free trial. If you do want to follow along, you can actually use the coupon code LeonVanSale, and that will add $20 to your account. Then let's go to account settings, go to users and API keys. Then under API keys, I'm simply going to refresh this key. So let's copy it. And now back in our project, what we have to do is go to this env.example file. I'm just going to hide the terminal for a second. And let's rename this file to .env. Cool. Then let's paste in this Bright Data API key. And please use your own key. I am going to delete this one after the recording. Now, what I've already pre-populated for you as part of this template are these data set IDs for ChatGPT, Perplexity, and all the different providers. And you might be wondering where this actually came from. Well, it's actually really simple. In the Bright Data dashboard, simply go to Web Scrapers, go to the Scrapers library, and from here you can search for any of the scrapers supported by Bright Data. For example, ChatGPT. If I click on this will take us to the details page for this web scraper for ChatGPT. And there's a few very important things here. First, we want to get that dataset ID. Now, I really couldn't find an elegant way of doing it, but you can actually get it from the URL. So just after scrapers, / grab this value starting with GD, and then grab the entire value up until the next front slash. So I'll just copy this. And then that should actually match the ID I already have in this file, which it is. Now, what you will also notice is that this scraper requires certain fields, and these are mandatory. We must pass the URL, which is simply the path to the actual website, like chatgpt.com. We also have to pass a prompt. So we've got a few examples over here. Then optionally, we can also specify a country. So if you want to see how ChatGPT would respond based on a certain geolocation, we can definitely pass the country as well. And this information is really important because it does differ per data set. But an easy way to get Claude Code to implement exactly what this needs is to simply open up this tab, which gives us an example request. So we can easily just copy this code and ask Claude Code to mimic this behavior. Now, we won't worry too much about these properties yet. At this stage, we just want to connect to Bright Data, and we want to set up any data sets that we want to scrape. So if you're following along, you can just simply delete anything you don't want, or if there's an additional source that you might want to include, simply search for it from this library and add it to this .env file. Alright, cool. So now that we know what APIs we need to use and how to use them, we can finally work on the fun part, implementing the scraper logic into our application. At the moment, the run scan button does nothing. So what you can do now is switch over to your code editor and open up your coding agent. Whether that's now Claude Code or Cursor in my example, it's really up to you. The first thing I'm going to do is switch over to plan mode, and I encourage you to do this as well. Then we'll start off with a really simple prompt. I need you to implement the run scan button. And this is where we're going to provide a lot of important context to the agent to help it build a robust solution for us. This is called context engineering. We're not just going to let the agent guess what it needs to do. By providing detailed instructions, we're going to get better results each and every time. And that is why this initial investigation was so important. So what we can do now is simply grab any of this documentation that we found useful, like this one on the introduction to the AI scrapers, and I'll just pass it into the chat. Then for the APIs, let's grab this one on the synchronous requests. I'll add that as well. Let's also grab monitor process, and I'll also grab snapshot input. And by the way, if you're uncertain about any of this, don't be afraid to provide more documentation. For example, I'm not sure if we should go with a synchronous option or async. So I'll just grab the async doc as well. And let's pass it to our agent. And this is also worth mentioning. If you are ever unsure, try to find documentation that can help you or example projects. Like I was also able to find this Bright Data article on building an LLM mentions tracker, which is, again, the same thing we're building. And this article does a brilliant job of walking you through the process, but this is a Python project, and of course we're building a web application, but this could still be valuable information to the agent to show kind of how this entire workflow works. So I'm going to copy this article as well. Here are some examples of how this could work. I'll paste in that link. And then I also found this GitHub repository that seems to be really similar as well. So it's this little SEO project using a unified LLM scraper. So this might be useful as well, and it does use the same Bright Data tech stack as well. So I'll simply copy this and give it to our agent. And this is something that people seem to just not do. When you prompt your agents in planning mode, try and provide as much context as you can, or examples even. So using the above resources and examples, I need you to come up with an implementation plan for our application. At the moment on the UI, we've got several providers set up, like ChatGPT, Perplexity, etc. And for each of those, we need to run this scraper, so this entire workflow where we do a trigger, we poll, and we download the results. But we have to do that for each and every one of those providers, including SERP, by the way. Then on the UI, we want to show the progress of the scraping for each of these providers as cards, and then we want to show the results and whether or not the brand was mentioned in the results as well. Do keep in mind that each of these providers could require different inputs that need to be passed to it, and the response shapes could also be slightly different. Alright, I think that's a lot of really clean context, so I'm just going to send this. Alright, cool. So let's have a look at the implementation plan. So looking at this architecture, our client or our application is going to pass the information to the scans API, which is going to return the scan ID. And then we'll simply poll the status of the scan until we finally get the results back. So this is exactly what I wanted. I think we can actually go ahead and implement this. And you know what? Since we're using cursor, I'm going to press Ctrl and E just to switch over to agent mode. It just makes it a little bit easier to see what the agent is actually up to. Right, so Claude completed all of these changes. So I'm actually just going to restart the dev server. Then let's pull up our app. And just to keep this really simple, I'll first run with SERP API only. So let's run the scan. The button seems to be doing something. We're currently scanning. And I can see the SERP API card down here, which is currently pending. So basically we've now gone past the trigger point, and now we're in the polling phase. And finally, we get the results back. And if we open this up, I think let's do one more. Let's also click on ChatGPT, and let's do Copilot as well. Let's run the scan. So while this is running, I can already see that Copilot failed, and that is because we're not passing a certain input parameter. And like I mentioned earlier, that is because each of these different providers could expect different types of inputs, and their responses could be slightly different as well. So how do you solve an issue like this? Well, it's really, really simple, but I do want to point out that ChatGPT actually did work, which is really good news. But now we just have to solve Copilot. So back in Bright Data, we can simply go to Scraper Library, and let's look for Copilot. So we can open up its details page. So what we could do is simply copy this example request. Then let's go back to our coding agent, and let's say, it seems like SERP is working as well as ChatGPT. But I also tried to run it against Copilot, which failed. I'll just grab this message. I'll just paste in that message over here. Here is an example request for scraping Copilot. Maybe this will help you. Let's paste in that entire sample payload. 2 issues to fix. The Copilot URL, which is supposed to be this, not that. And the country field, the working curl sends the country as empty, not US. Hardcoding US may cause validation errors for providers that don't support it. So it's just going to make the country optional depending on the provider. I'm actually just going to select all of these providers to see which ones come back with any failures. Oh, and by the way, if you're wondering how I know if a brand is actually mentioned or not in a response, this is not coming back from the Bright Data API. It's actually a really simple piece of code in our application itself. It simply looks at the response string, and then it just sees if that brand, so this exact wording up here, fresh desk, it just checks if this word appears anywhere in the response. Nothing insanely complex about it at all. Well, the good news is all of these other providers are working as well. But to be honest with you, for completeness sake, I would probably go through this Bright Data platform just to grab the example payloads for each of these providers. I would then pass it to the agent just to ask it to ensure that we've actually covered everything that could be sent to them. It's possible that the country is actually supported by the provider, but we're missing out on sending the country because we haven't actually coded for it. And now the good news is Copilot is working as well as ChatGPT. How awesome is that? Let me show you a really cool trick. So the way we solved this problem was by giving it very specific instructions, right? Like this example payload. But what if you actually didn't know about this? What if you didn't know that this was even an option? What other techniques can we use to solve these problems? Well, firstly, we could ask our agent to write very clear error messages to the terminal or to the browser as well. So to the browser console, so that you can pass it back to the agent to try and resolve the issue. Another really useful trick is this. Tell your agent that you're running into issues which you can't figure out. So it should add any logging to the run scan function and then write those detailed logs to a debug file. And it must let you know once it's ready so that you can kick this process off again. Once the process is done, you will tell your coding agent that you're ready, you've run the process, there are failures again, and it will pull in that debug file to see exactly what went wrong and resolve the issues. But for us, this actually worked and I'm really happy with the results. But we're not done yet. You might recall from our requirements that scraping these sources were just one part of the solution. To make this something that businesses can actually use, we need to make it robust. So we do have to add retry capabilities, we need to handle different response formats, and this needs to be able to run reliably at scale. We've already handled point 2, where if we run into any issues, really, we could just give these example payloads, get our coding agent to build something that's robust, like a separate helper function or proxy for each of the different providers. But the solution we have now is perfectly fine. What we don't have is a solid solution for running these different scrapers in parallel. At the moment, they're very much just synchronous. And we don't have any retry capabilities either. Like when the Copilot scrape failed earlier due to a technical failure, we had no way to restart that process after implementing a fix. And of course, as we scale this application, we could run into all sorts of rate limits when we have multiple users running these scrapers at the same time. So we might need a solution to kind of queue or throttle the amount of requests that we're making in a given period of time. So that's exactly what we'll implement now. Right, so now to make this application as robust as possible, we will add the ability to run these scans in a background queue. This means you can hit scan, you can close the browser, restart your computer. Heck, even the backend server can get restarted, and these processes will simply pick up once the server becomes available again. That's the kind of robustness we really want. So the easiest solution to build something like this is to install Inngest into our platform. So we can simply go to the Inngest docs, and under Get Started, let's click on Next.js. Then I'm going to copy this URL. Then I'm actually going to start a new session just to clear up the context window. I'm going to paste in the URL to Inngest, and let's say, all right, so the app is working correctly now. I can see all the different providers and we're able to scan them. But now we have to focus on getting this application as robust as possible. So what I'm thinking is we need to move the scan functionality, so that the entire architecture around triggering the scrapes, polling for the results, downloading the results, all of that needs to happen in an asynchronous process using Inngest. This means that the different scrapers for each of those providers can run in parallel in Inngest. We should have the ability to restart these jobs if they failed due to any technical failures, as an example. And maybe you can implement some kind of concurrency limits, like we should only be able to run, 5 scraping jobs at the same time, just to avoid hitting any kind of rate limits with these providers. I need you to really think about the user experience here. The idea is for the user to hit the scan button and everything should just run in parallel. They should be able to even close the application in the browser and come back whenever the results are complete. Let's send this. Okay, cool. So our agent is now installing the Inngest SDK package. Then it's going to create our Inngest client, the Inngest functions, and just move all of these functions over to Inngest. Right, cool. So according to the agent's very own testing, everything seems to be working. But of course, we want to test all of this ourselves, so we won't just take the agent's word for it. What we have to do is ensure that our dev server is actually running. Then we also have to start Inngest. So to start Inngest, you can just run the command npm or pnpm dlx ingest-cli add latest and dev. When you run this, it will give you this localhost URL. And if we open that URL, we can see our Inngest dashboard. At the moment, we don't have any runs. Let's actually create a new project. I'm going to call this SEMrush. Let's create this. SEMrush is a really popular SEO tool, so we can see if they're actually mentioned as well. Then for the prompt, let's enter what tools monitor search results in LLMs. Now I'll select all of these providers. Then we can hit run scan. And while this is running, so of course this will create all of these little cards for us. But now if we go to Inngest, we can see a run for each of those different jobs. And if we open up any of these, we can see exactly what's going on. So here's a step to trigger the scrape. So that was step number 1 in the process. Now we're polling the results. So every few seconds, we'll poll again until we get those final results back. And if anything fails during this process, like if there's a technical failure or I don't know, something went wrong, this job will show red and we'll be able to restart it. In fact, if I open up this job, we do have a cancel and a rerun step. So if something goes wrong, we can easily rerun this process. And we can see that some of these jobs are already completed. So if we have a look at our application, we do indeed see the results coming in. And the nice thing is the user can actually close his browser. The dev server could even fail. It doesn't matter. Inngest will automatically retry these processes for us. And there you have it. This system will be able to scale this application to thousands of prompts and users. So if you have been following along with this tutorial, here's a little challenge for you then. We can also use Inngest to set up scheduled jobs. So what you can do is ask your agent to add the ability to schedule a scan to run maybe every hour, once a day, once a week. It's really up to you. What Inngest will do in that case is it will run every minute, and it will check to see if there's any jobs that actually need to be fired off automatically. And it should be able to view all of those scheduled executions in your scan history. For an application like this, building that scheduling system could be very useful. And that is because of drift or variance in the LLM's responses. Just because ChatGPT didn't recommend the brand this time around, the response could look very different in an hour or even a day from now. So it's worth kind of setting up these little systems to automatically scan and track the mentions. So that way you've got a scheduling system, you've got historical data, and what you could also do is set up alerts. So maybe you can allow the user to receive alerts to their phone or to their email if certain events occur, like when their brand is no longer mentioned by an LLM, or if it now is being mentioned due to a campaign. I really would love to see what you come up with. So please share your thoughts in the descriptions below. If you enjoyed this video, then hit the like button and subscribe to my channel for more Claude Code and agentic coding tutorials. Also check out this other video where I show you how to build beautiful UI designs using Stitch and Claude Code. I'll see you in the next one. Thank you for watching. Bye bye.